Hi, Assalamualaikum warahmatullahi wabarakatuh. I will present for final year project dissertation MEC 601, which is development of a biohybrid electrical powertrain for mountain bike MTB. First of all, let me introduce myself. My name is Shamsul Ridzuan bin Mohamad Kasim. My student ID 2019582665. And my supervisor is Professor Madya Dr Ramzyzan Ramly. In this presentation, I will present for the project summary, introduction, methodology, and lastly is expected result. Firstly, project summary. This project aims at the development of biohybrid electrical powertrain for mountain bike MTB that combine the pedaling power of the rider with the power of an electric motor. In this mountain bike, the battery utilized for electric motor that will be charged when the rider pedaling the mountain bike. The generated electric will be moved the bike. A powertrain in the bicycle is a system of mechanical parts which convert the energy from the pedaling to the power through specific gear ratio and transmit it to the wheel of mountain bike. Next is introduction. Presently, the necessity to reduce air pollution together with the aging of the population has led the research in the mobility field. In particular, biohybrid mountain bike refer to the mountain bike is a human electric hybrid bicycle that support the rider with electric power only when the rider is pedaling. In Europe, it is also called pedelec. The pedelec has a driving torque that comes from both the electric motor and the rider. This vehicle offers benefit of improving the mobility capability of normal bicycle through electrical assistance as well as being environmentally friendly as zero emission vehicle. This project also presents properties of an electrical powertrain designed for a mountain bike, design consideration of powertrain as well as inverter, electrical motor, and lastly battery. Next is advantages of biohybrid mountain bike compared to normal bicycle. Firstly, quite helpful uphill. Next is high speed. Other than that, suitable against annoying headwind. Helpful for older pupil and pupil with health issues. Next is longer distance travel, and lastly, less physical effort needed. This slide shows schematic diagram of biohybrid powertrain for mountain bike. The component used for this project is 1A is pedal, 1B is pocket size 12, 2A is pocket size 56, 2B is generator 400 watt, 2C1 is display, 2C is motor controller, 3A is inverter, 3B is battery 24 volt, 3B1 is battery display, 4A is electrical motor, 4B is gear, BBM is bottom bracket main, BBI is bottom bracket intermediate. Literature review. Major component of biohybrid mountain bike. Firstly, electric motor. In general, your motor provides more freedom when it comes to shifting the torque or speed, but they wear out faster and will lower transmission efficiency. Brushless DC motor are more powerful than brush motor, but they are more difficult to regulate and more costly system. Next is battery. Electric motor can be powered by a variety of battery systems. Lithium-ion cell is the best power-to-weight ratio than others, although also have regenerative braking system concern. It is also important to note that location of battery can have a big impact to the bicycle center of gravity and contribute it stable or not. Next, the diagram shows location of battery in bicycle. A. The battery is above the rear wheel. B. The battery is below the crossbar. C. Battery as rear panniers. D. Battery behind the seat post. E. Above front wheel or as front panniers. F. The battery is built into the frame or wheel. Powertrain system for bicycle. The powertrain is the system that transfers the electric motor power to the bicycle. In fact, compared to the front and rear hub propulsion, mid-drive type is more energy efficiency and has many benefits than others propulsion. It should be mentioned that hub motor with more 200 watt should not be utilized on aluminium. So, hub motor must be equipped with torque arm. Next is benefit of mid-drive propulsion compared to front and rear propulsion. Firstly, more steady behavior, then better performance in high mountain, and smaller battery requirement, ease of bicycle maintenance, less influence on tire life. Lastly is compatibility for use with bicycle gear. This slide shows hub type powertrain. The red shows the location of the motor. A is mid-drive propulsion. The motor transfers power directly to the drivetrain. B is front hub propulsion. Motor is placed to spin the front tire. C is rear hub propulsion. Motor is placed to spin back tire. Next is bicycle dynamic. The motion of bicycle obeys Newton's second law, which is Fp minus total Fr plus Fs plus Fw equal to m times dx square over dt square. For total driving torque, Tdw can be described by R times total m times dv over dt plus Fw plus Frr plus F alpha, where Fp is propulsion or thrust force provided by motor and rider, Fr is rolling resistance force, Fs is slope resistance force, Fw is aerodynamic drag force, m is total mass of bicycle and rider, x is distance in meter, r is nominal radius of both bicycle wheel in meter. For Fw, it can be described by 1 over 2 times As times Cw plus rho a v squared, where As is reference area of bicycle rider system, Cw is the aerodynamic drag coefficient, rho a is air density. For Fr, the equation is CRR times mg cos alpha, where g is gravitational acceleration, alpha is slope of road, and CRR is rolling resistance coefficient. For Fs is equal md sin alpha. The next literature review is motor dynamics. The electrical behavior of brushless DC motor can be described in the equation of LA times DIA over DT plus IA times RA plus KB times omega M equal to UA, where IA is armature current, RA is armature resistance, UA is terminal voltage of brushless DC motor, LA is armature inductance, KB is back EMF constant. The mechanical behavior of the brushless DC motor can be described joules times d omega m over dt plus BL times omega m plus TL equal to KB times IA, where joule is torque of inertia, BL is viscous friction coefficient, TL is load torque, omega m is speed of the motor. Next is problem statement. According to previous study on a hybrid electrical bicycle, the decrease of petroleum and the increase in greenhouse gas emission are factors that contribute to the development of bio-hybrid bicycle. Problem with electric assisted bicycle or pedelec include a quick driving force when motor is initiated. Other problem is lack of cycling facilities. And lastly, the weather, especially rain, also has been reported in previous research. For this study, the objectives are: firstly, to study the electrical powertrain control system for mountain bike MTB. Next, to review the components used for bio-hybrid bicycle for better quality. And lastly, to develop an environmentally sustainable form of transportation as an alternative to petrol vehicle. Limitation of project. The limitation for this project is due to movement control order MCO, which caused of the COVID-19 outbreak. The experiment could not be conducted physically in the laboratory. This project need to build a prototype and working test bench at Lab Aero Laboratory. A test bench is an environment where software and hardware tools are used to test the product development. The next main topic that I will present is methodology. The diagram shows the flowchart of methodology for development of this project. First, start. Next is problem identification. Identify the problem that need for development of bio-hybrid mountain bike. It focuses on powertrain system in bicycle. After that, literature review. Review on previous research by reading journal related to obtain further information and concept to carry out the experiment. Next is determine the electrical powertrain for mountain bike. If can enter UiTM, experiment in the laboratory and fabrication will be done. Testing workbench for brushless DC motor will be conducted. If no, simulation using CATIA software and ASIS software will be done. Next is data collection and analysis. The data from simulation and testing will be analyzed for the result and discussion will be made. And lastly is report writing. The last main topic that I will present is expected result for this project. At the end of this project, an understanding of biohybrid concept for mountain bike MTB is expected. Other than that, the expected result from this study is the development of electrical powertrain for biohybrid mountain bike MTB. The working principle of this bicycle is simply starting from stationary state to move. It is used an electrical power source from a battery that will be charged during pedaling to be able to drive the electrical motor. Next, to determine the best component type for biohybrid mountain bike. Lastly is fabrication of component to mountain bike. That's all from me for final year project presentation MEC 601. Thank you.